absolute maximum and minimum homework help. We have this exercise on finding absolute maximums and minimums within a domain. I want to go over a few of these problems. We're going to look at problem 2. Find the absolute maximums and minimums of f on the given closed interval and state where these values will occur. I'm going to look at problem 2 now, and print may not come out too well, but that's this function here, f of x equals 2x cubed minus 3x squared minus 12x minus 1. And we're given the interval, the closed interval, from -2 to 3. So let's go ahead and find the critical points in this function to see if they lie within these endpoints of -2 and 3. And so we're going to find first f prime of x. F prime of x is equal to 6x squared minus 6x minus 12. And we're going to now find the critical points by setting this first derivative equals 0. So 0 equals 6x squared minus 6x minus 12. And factoring, we have, looks like your 6 will be factorable out of all of these guys. So 6, that's going x squared minus x minus 4. And so solving, we can divide both sides of the equation by 6. We have 0 equals x squared minus x minus 4. And then 0 is equal to quantity x. This would be x and x. Let's see. Factors. Oops, I kind of made a mistake here, didn't I? I should have -2 up here. Okay, that makes more sense now. That's -2. Do the incorrect factoring. There we go. Now it'll work. So we're going to have, I think it's going to be 20x minus 2. That's 20x plus 1. And so, besides setting each factor equals 0, we're going to have x equals 2, x equals -1. That's where the particles are at rest. And so what we have now is we find out if function changes at these endpoints, at these points of -1, 2. So we have f prime of x on top and f of x on the bottom. And we evaluate, well, if we have a value of x less than -1, is the derivative positive or negative? Well, less than -1, this would be like say -2. Well, -2 plus 1, that's negative. -2 minus 2 is negative. Negative times negative is positive. So we have the function going up at this point. And then, let's see, value maybe 0 between -1 and 2. That's going to be negative times positive is negative. So we're going down in this interval. And then the last one to the right of 2, let's say 3. Well, 3 minus 2, positive, x plus 1, positive. So we have candidates. This one at -1, that's a candidate for an absolute maximum. At 2, that's a candidate for an absolute minimum. So now we can construct what we call a candidate test. And this is the one justification on the AP test where you can just maybe have f of x and we list our candidates. Our candidates are our endpoints. We got -2, -1 from our test, and 2, and 3. So if we test all of these, we will figure out what's going on. Okay, let's test our candidates. Well, at 0, and we don't have 0 as one. Let's see, we got to put f of -2, and we have to go back to our original equation here. So we have 2 times -2 cubed minus 3, -2 squared minus 12 times -2 minus 1. So this is going to be -2 cubed, that's going to be 8, -8, so -16. And then -2 squared, that's going to be 4, +4, so minus 12. And we have minus, let's see, minus times minus positive 24, minus 1. So we have -28 plus 24 minus 1, -28 plus 24 is -4 minus 1 is -5. So -5 is one of our candidates. Okay. Next, we go to -1. F of -1 equals 2 times -1 cubed minus 3 times -1 squared minus 12 times -1 minus 1. Here we have -1 cubed, that's going to be, it comes 2, it's going to be -2 minus 3 times 3 minus minus, so minus and minus, that's going to be plus 12 minus 1. So -2 minus 3 is -5 plus 12. -5 plus 12 is 7 minus 1, 6. So 6. It's going to be the absolute maximum candidate. Okay, now we're going to find f of 2, which equals 2 times 2 cubed minus 3 times 2 squared minus 12 times 2 minus 1. So this is going to be 2 cubed, this is going to be +16 minus 3 times 4, so minus 12 minus 24 minus 1. 16 minus 12 is 4 minus 24, we have 4 minus 24, that's -20 minus 1 equals -21. -21, that's a candidate for absolute minimum. And let's see, f of 3, our endpoint, we're going to be going up again. So that's going to be 2 times 3 cubed minus 3 times 3 squared minus 12 times 3 minus 1. 2 times 3 cubed, that's going to be 2 times 27, which is 54, minus 3 times 3 squared, so that's going to be minus 3 squared is 9, that's 27, and minus 12 times 3 is minus 36, and then minus 1, so 54 minus 27 equals -27, minus, let's see, that's going to be +27, 4 minus 27, minus 36, minus 1. So 27 minus 36, that's -9, minus 1 is -10. So -10. So we call this, we go back, and this is one of the things, the justification on AP test, we don't need to have, we can just circle. So our absolute min is going to be negative 21. So absolute min, and our absolute maximum is going to be this one here. At negative 1, we have 6. Okay, candidates. All right, let's go on to look at 4. Okay, we have this function here, f of x equals quantity x squared minus 2 to the 2/3 power from the closed interval of negative 2 to 3. So we're going to find f prime of x, and that's going to be this quantity here. We're using our power rule and the chain rule combined. So we're going to have 2/3 of x squared minus 2 to the 2/3 power minus 1, which is going to be the negative 1/3, and times the derivative of the inside the chain rule is 2x. Is the derivative of x squared minus 2 is 2x. And combining, we're going to have 2x times 2, we'll have 4x over 3. This thing right here to the cube root of x squared minus 2. This is going to be our first derivative. And so we need to find where this first derivative is equal to 0 or is undefined. And to do that, we'll say 0 equals 4x over 3 cube root of x squared minus 2. And so we know that that we can set this numerator equals 0, so 4x equals 0, and that's x equals 0. That's going to be one of our possible critical points, critical number, excuse me. And then where the function is undefined would be where the denominator is equal 0, so we set the denominator equals 0. 0 equals 3 cube root of x squared minus 2, and dividing by 3, we have 0 equals cube root of x squared minus 2, and cubing both sides, we have 0 equals x squared minus 2, and then adding to both sides, we have x squared equals 2, so x equals plus or minus square root of 2. And square root of 2 is going to be inside of all these guys. So we have a pretty hefty candidates test here going on. And I'm just going to write out the candidates right now. Let's see, we have x, f of x. All right, we have our endpoints here. We got negative 2. We got negative, let me put this on here, negative square root of 2. We have 0. We have square root of 2. And we have finally 3. So those 5 candidates we had. All right, I'm going to now, I should really do this. Okay, we're going to try the candidates. We have negative square root of 2, 0, and square root of 2. And we're going to have f prime of x on top and f of x on the bottom. And at here's our derivative right here. So at less than square root of negative square root of 2, we'll say negative 3. Well, at negative 3, we would have this here. Turn off that alarm. Okay. We have, go back again. Okay. So negative 2, if we plug in negative 2 to this, or negative, we plug in negative 2. So negative 2, we plug in, so we got 4 squared. Let's see, that would be 4. That'll be negative 2 minus 2 will be positive. So this thing is going to be positive to the actually it'll be negative because this thing up here will be negative, positive. So we're going to have negative. So negative. So we have the function start out going down. We pick a number between negative square root of 2 and 0, which would be, let's say, negative 1. Negative 1 squared minus 2, that's going to be negative, and this will be negative. Negative divided by negative is positive. So we're going up here. We pick a number greater than 0. Let's say 1, between 0 and square root of 1. Well, 1, well, that's going to be positive. And 1 squared minus 2, well, that's going to be 1 minus 2 cubed here. That is negative. Get negative. And then on the right of square root of 2, let's say at 2, well, that's going to be positive, and 4 minus 2 is positive, so that's positive. So this is what it looks like. Now, every one of these things is a candidate. So first of all, we plug in negative 2. We're going to say f of negative 2 is going to be equal to, let's see, negative 2 squared minus 2 to the 2/3 power. Well, negative 2 squared is 4 minus 2. So we're going to have 2 to the 2/3 power. Well, 2 squared, let's see, is 4. So we're going to have the cube root of 4. So cube root of 4 is going to be that first candidate for minimum maximum. At negative square root of 2, well, negative square root of 2, we're going to say f of negative square root of 2 is, we have negative square root of 2 squared minus 2 to the 2/3 power. Well, negative square root of 2 squared is 2, so we'll have 2 minus 2, so we'll have 0. And for this candidate over here, f of square root of 2, we're going to have the same thing because we're going to have square root of 2 squared minus 2 to 2/3. So that thing's going to be 0 over here. Now to plug in 0, f of 0, we're going to have, let's see, well, if we plug in 0, well, 4 times 0 is 0. Oh, we got to go to the original equation. Here we go. That's something's messed up. Okay, we're going to have negative 2 to the 2/3 equals negative 2. Let's see, the 2/3. Well, negative 2 squared is 4, so that's going to be 4. So that's going to be cube root of, okay, good. And then last thing we pick is 3. F of 3 equals, we have 3 squared minus 2 to the 2/3, and that's going to be 9 minus 2. That'll be 7 to the 2/3. So that's going to be cube root of 49. Cube root of 49. So we have our absolute maximums and minimums. Okay, our absolute maximum is going to be this higher number here. This will be our max, absolute max. Square root of cube root of 49. What's that going to be? Well, cube root of 64 is 4. Let's see, cube root of 27 is 3. So it'll be between 3 and 4. And our minimums will be tied, so absolute minimum will be 0. And this will be like a corner. So anyway, that's going to be problem number 4. Next, let's look at 9. What is the smallest possible slope to y equals x cubed minus 3x squared plus 5x minus 1? Well, to find the slope, we need to find the first derivative. So we're going to say y prime equals 3x squared minus 6x plus 5. And we're trying to find what the smallest possible slope. This is the slope generator. So to find the smallest possible slope, we need to do a candidate's test to that. And to do that, we're going to take y double prime is equal to, well, let's put 6x minus 6. The smallest possible slope, let's see, 0 equals 6x minus 6. X equals 1, that's an inflection point. But really, on this one here, if we set this to 0, the smallest possible slope would be what this function is doing. The cubic one is going like this. So your smallest possible slope is going to be in here someplace. And it's going to be at this inflection point. And so at x equals 1, that's going to be our smallest possible slope, because everything here is going to be big on this where the function's increasing. That's big. This is big. So all we need to do is plug in 1 to our slope generator. So we say y prime of 1, and if we're right, this should be negative 3, 1 squared minus 6 times 1 plus 5. We have 3 times 1 squared, that's going to be 3 minus 6 plus 5, which equals 6, negative 3 plus 5, equals 2. That's going to be our smallest slope. just to check, I'm going to be sure and try to figure this one out. Let's see, if we try to find 0 equals 3x squared 6x plus 5, we're going to have 0 equals 3x x, and we're going to have, let's see, 5 and 1. We're going to say 5 here, negative 5. We'll say minus 1. So that's going to be negative 5. Let's see. Anyway, that's the best thing I have right now. I'm going to check it. Anyway, this has been some homework help. I hope this has been helpful. And thank you for viewing. Bye now.